Okay, we'll be graphing transformations of arbitrary graphs. So, the middle section here is for your work. If you choose to use it, that's fine. I always like to provide it, but the final graph will go to the far right, and that's what we're going to do right now. I'm going to take each individual coordinate point that is key. For example, if I started with this particular corner piece right here, which is 1, 2, 3, 4, 5, 6, 7, 7, 0. I like to move it left or right first. In this case, the x minus 2 means we're going to move it to the right 2. So that coordinate point moved right 2 would put me here at 9, 0. At that point, I take the a value out in front, which basically multiplies the y value by the number that it is. The current y value after you move it to the right 2 is 0. 0 multiplied by 1/3 is still 0. So after moving it right 2 and multiplying by 1/3, you're still in this location. Last, and always last, is the up or down shift. In this case, the +3 means to move it up 3, so that would place me here at 9, 3. So 9, 3 is the coordinate point I'll make in my final graph, which is a point that should be checked. I'll write it over here, 9, 3, and the graph exits to the right, going straight across. So I've just moved this section. The next pretty corner that we should graph is this guy here, which is 4, 6. So 4, 6 is the coordinate point that we're going to move. First shift is to the right 2. 1, 2, that would put me here. Now, my y value that I'm pointing to is positive 6. If I multiply that by negative 1/3, I would get negative 2. Negative 2 is down here, staying on the same x value that you currently were. Once you multiply it by negative 1/3, which gives you the negative 2, you move it up 3, the last shift, which puts you here. That's your final destination of that coordinate point. 1, 2, 3, 4, 5, 6, 1. 1, 2, 3, 4, 5, 6, 1. And now you can connect that to the point you found previously. So you'll notice this stretch here, which was steep, has flattened out quite a bit. And multiplying by a fraction there does flatten out the graph, or make it fatter. Now we can do this coordinate point and go through the same shifts, or we can just recognize that it is 3 units directly to the left of the unit we just found. We just found this coordinate point, so 3 units to the left, straight across, is that coordinate point. Saves us a little time, shortcut a little bit. So the next coordinate point we're going to move is this one, negative 2, negative 3. First, we move it to the right 2. That puts me here. Multiply that y value, which is negative 3, by negative 1/3, which would give me positive 1. Then move that up 3, and I end up with 0, 4. 0, 4 is my endpoint. Now I can connect these. Now, instead of just drawing an arrow that exits to the left in this graph, I should be fairly accurate. So I need to look at this left side of this vertex that we chose, choose another coordinate point, and regraph it. So, for example, if I chose this coordinate point, negative 4, 3, move it to the right 2, multiply the y value by negative 1/3, which would give you negative 1, and then move that up 3, you get to the final destination of a point that will allow you to draw a graph fairly accurately, negative 2, 2. And now you can draw your final line as best you can through that point. Okay, I'm going to throw up problem number 2. So I'm going to leave that up there just for a moment. Go ahead and press pause this time, and I'll put the answer up as soon as I can at time. Press pause. Okay, here's the solution to problem number 2. I put up a couple of coordinate points that you should check to make sure match mine. Those are the 2 that I would grade. If you need more time, press pause. Otherwise, here's problem number 3. Okay, press pause. Work on that problem. And there is your solution to problem number 3.